Using 75 ohm television cable like RG6 or RG59 for an amateur radio feed line is not only possible but in certain scenarios actually advantageous. The amateur radio standard is 50 ohms, but the impedance mismatch is easily manageable. Here is exactly how to integrate 75 ohms coax into a 50 ohm station. When you connect a 50 ohm transmitter to a perfect 50 ohm dummy load using a 75 ohm cable, the resulting standing wave ratio is simply the ratio of the impedances, that is 75 by 50, 1.5:1. An SWR of 1.5:1 is perfectly acceptable for modern transceivers. At this ratio, only about 4% of your transmitter's power is reflected back to the radio, meaning 96% of your power still reaches the antenna. A transceiver's internal automatic antenna tuner will instantly flatten a 1.5:1 mismatch, allowing the radio to deliver full output without folding back. Feeding half-wave dipoles. A resonant half-wave dipole in free space actually has a feed point impedance of roughly 73 ohms, not 50 ohms. If you are stringing up a standard wire dipole for an 80 meter or 160 meter band, 75 ohm coax is mathematically a better match at the feed point than 50 ohm cable. Because the antenna's impedance closely matches the cable's impedance, the SWR on the feed line remains practically 1:1, and the 1.5:1 mismatch only occurs right at the transmitter where an ATU handles it easily. VHF-UHF satellite operations. High quality satellite TV RG6 has excellent shielding and very low loss at VHF and UHF frequencies, often outperforming standard 50 ohm RG58 over long runs. For LEO satellite work using a Moxon-Yagi hybrid or similar directional antennas, the lower signal loss of RG6 easily outweighs the minor 1.5:1 SWR penalty. Quarter wave matching transformers. You can use a specific length of 75 ohm coax to match a 50 ohm feed line to a higher impedance antenna like a delta loop or quad, which sit around 100 to 120 ohms. A quarter wavelength section of transmission line acts as an impedance transformer according to the formula Z0 is square root of the product of Z in and Z out, where Z0 is the 75 ohm coax. If you connect your 50 ohm transmitter, that is Z in, to one end of a 75 ohm quarter wave section, the other end will transform the impedance to exactly 112.5 ohms. 75 is equal to square root of 50 into 112.5, providing a perfect match to loop antennas. But there are some catches. If you decide to use 75 ohm cable, you must navigate a few physical limitations. The aluminum braid. Most modern RG6 uses an aluminum foil shield and aluminum braid. You cannot solder aluminum with standard tin lead solder. Do not attempt to solder a standard PL259 UHF connector directly onto RG6. The connection will eventually fail or corrode. The connector solution. The most reliable method is to use a high quality weatherproof compression F connector designed specifically for RG6. Once the F connector is properly crimped on, attach a simple F female to PL259 or BNC to SMA adapter to connect it to your radio or amplifier. Power handling. Standard RG6 can easily handle a 100 watt output from a linear amplifier without dielectric breakdown or overheating. However, if you ever plan to run full legal limit, that is 1500 watts in the US, RG6 will quickly overheat.